Hello, everyone. Welcome to episode 138, the 27th Data Science Sunday of the year. Yes, the 27th Data Science Sunday of the year. Just hold on a bit. Let me be sure. Yes, episode 138, the 27th Data Science Sunday of the year. Hello, everyone. Welcome. My name is Pablo. I am your host of the Data Science Sunday. I am a data science professional, data science educator, data science curriculum manager, data science instructor, a data science content creator and partner. And I lead the data science community at Collab Innovation Hub, one of the first innovation hubs in northern Nigeria. So welcome to Data Science Sunday. First, I like to share, just like for the past 137 episodes, I like to share why the Data Science Sunday is such an important community. I also like to share why the Data Science Sunday is critical to your data science career. I would also share why Collab Innovation Hub is driving such, is passionately driving community and building tech skills using community as a driver. Right. So Collab Innovation Hub is building a tech ecosystem in Nigeria. Next year will be 10 years old. We started off by the idea of getting people together as a community so as to build products and startups. And somewhere down the line, the idea of having skills became pertinent because you learn as you grow. And so we started building an ecosystem with a focus on talents, products, startups, policy and advocacy, labs, partnerships, funding, a bunch of things, right? And these things are part of the pillars. These are part of our drivers to build the tech ecosystem here in Kaduna, right? And so with that, the vision kept growing. So community members come in and take ownership. And so to that end, we have different tech communities, and data science is one of them. Now, Data Science Sunday is a physical our data science community has a physical setup at our hub and campus. However, we didn't have a virtual community. So on the 6th of November 2022, we started our first episode of Data Science Sunday. The Data Science Sunday is dedicated to anyone learning data science from scratch, needs a community to come together, build their skill, and also, build that ecosystem in a virtual space where folks with data skills can move from, the hello world of learning to the future of work. And so we use this as an opportunity to learn, an opportunity to hear from folks who are learning in different spaces wherever they are in the world. Right, so that's what we do here at Data Science Sunday. Now, Data Science Sunday every episode has two sessions. The first session is an introductory session where we share why we're here, hear from attendees, hear from folks who are building their data science careers, wherever they are, the challenges they have. We also use the first session to share any resources we have, encourage folks to join our community, and talk about what we've done, what we do every week. The idea is to build consistency as we build this ecosystem here, right? So that's what we are about. So in the first session, we'd hear from folks. If it's your first time, please feel free to share. If you have learned anything in the week, feel free to share. If you are having any challenges, feel free to share. And while we're at it, we just share what folks around also share the resources they have, the updates they have, the challenges they have. Now, the second session is a technical session. It's almost always a technical session where we talk about, we just share what we can, right? So as a host, I almost always share stuff, but it's also open to anybody who wants to share. So what we do is before each session, we meet and we just exchange thoughts, and then um, when it's time for the technical session, then the community member goes ahead to share what they have. The idea, sharing is such a super opportunity for folks to learn, a super opportunity for folks to carry on what they're learning, a super opportunity for folks to also share their thoughts and have very educative and mutual um, agreements and disagreements about the field of data science and machine learning. Right, so that's it. So the question will be thrown to the first session of this episode, which is, what did you do this week? Are you new? If you're new to Data Science Sunday, please feel free to engage. If you want to engage, all you could do is basically raise your hand, and I'll let you speak. Right? If you can also use the opportunity to say hi using the in-call message area. Data Science Sunday is streamed live on YouTube, so you could check us out if you're here for the first time, or you want to see past episodes. You could check it out on the Data Science with Pablo YouTube channel, and you see the past episodes are there, well documented. Of course, we have to state that we started live streaming not long ago, so you probably get to see maybe 10, 11 episodes. Right. So, and please feel free to share the link with folks who may have missed other episodes, just to, to get a context of what we do. All right. So, again, back to the first episode, back to the first session. What have you learned this week? Are you new on Data Science Sunday? Feel free to share. So the floor is open. The proverbial floor is open. And so the virtual floor is open. And so while we're at it, I'll just share a few resources, links to help folks connect with the community. So the first, I like to share the WhatsApp and Telegram group link. I like to share the WhatsApp and Telegram's group link, and so just check out the in-call message area, and that's there. Right. So so I just shared is a group link for the Telegram group link and the WhatsApp group link. Now it has a very cheesy name. It's called the Data Weekend. Now, we chose to call it the Data Weekend because it's inspired by three communities: the data analysis community, the business intelligence, and data science. And in our physical community, all these three communities happen on a Friday, Saturday, and Sunday. Also, we also have an ML engineering community, and that also holds on Saturday by 1:30. So please feel free to jump in. We have a lot of communities coming up and so much opportunities to learn stuff as you go. So check out the link. I have it pinned in the message area, so you can jump in and share, talk to folks, and connect with folks. Right. Yes. So that's one. Which other thing? Yes, so I also like to share a link to the YouTube channel. On the YouTube channel, you'll find past sessions, past episodes of the Data Sunday that are streamed live. And you'll also find the Data Science channel, my Data Science channel, with different resources on building a data science skill. So please do check it out, like, subscribe, share. You know what it is. That's one. Then I like to also share this. like to share the latest edition of ThinkStats, learning data, exploratory data analysis with statistics and probability. Shout out to Alan Downey for creating these resources and making it free as as a cloud, a Google Colab notebook or a cloud or a Jupyter notebook in the cloud. So check it out. It could be something that you would fancy jumping on. So yeah, so that's what we have. Anyone wanting to share what they've learned for the week, please feel free to. Today's episode, we're going to continue from what we did last week. We'll be talking about the Scikit-learn's Estimator API and the principles that guide the use of the Scikit-learn Estimator API. Right, so we're basically doing introduction to machine learning at this point. Again, from the very start, we started with very basic stuff, but after 137 episodes, we're basically at machine learning, right? So again, anyone wants to share what they've done for the week? I mean, it's not mandatory, but if you have something you've learned for the week, please feel free to share. If there's nothing, I'll go ahead and share it and start the technical session. All right. Again, welcome to the Data Science Sunday. If it's your first time, please feel free to let us know. If you have something to share, also feel free to let us know. We'll let you share and we could start a conversation from there. All right. Emmanuel says this week, what has always been emphasized in the data weekend group hits home, the realization that learning a data tool is completely different from solving real world problems. To work on my problem solving skill, I engaged ChatGPT in building scenarios that help me hammer in lesson learned using real world scenarios. The difference is massive. All right. Well done. Well done. Yeah, using scenarios. I don't know if this is connected to the conversation we had around using ChatGPT as like like an interactive profile that helps you get through what you've learned, what you know, and stuff like that. But if that is it, that's awesome. Just keep at it. Keep generative AI tools help in many ways to build your skill and all. Of course, they're not 100% accurate, but also they are massive help in developing yourself. So it's a good thing to know that we can use them as assistants. All right, well done. Just like Emmanuel did, you can also drop your comments in the in-call message if you are in the session. If you're watching this live, you can also drop um, um, a comment in the comment section. All right, please go ahead.
Yes, what I'm trying to say is that when we are using ChatGPT for the data analysis, it do gives a when it reaches a level, it do says how do I call it, data analysis limits exceeded. But if we are using the paid ChatGPT website or the app, will it still give us um that same limit?
Okay. So I mean, folks on the call, you heard that question. For me, I haven't, to be honest with you, I've not reached a limit before. But then that's also down to how I. It's also down to how I use it. And but I'm also fortunate. I use the paid version, and I have never had that opportunity of reaching a limit. So I don't know if anyone using a paid version has had that. So yeah, Kabir, please go ahead.
Um, I just want to talk about the question he asked. This question, is he using the API or the web? because if he's using the API, that's when you have that error he's talking about. And if if you are using the API, usually they give you I think like $5 free. And once you exceed that, that's when you get that he's talking about rate limit. But
Okay.
if you are using the web interface, I don't think you experience that. What you have is you exceed a quota for a particular model, and once you exceed that quota, they like downgrade you to a lower model, and that's all that happens. But not that they will prevent you from using maybe before, maybe if you are on GPT 4.0, they might take you back to 3.5. Something I think that's what happens. But I don't think I've encountered rate limits unless when I'm using the API. Maybe when I'm prompting, maybe I create a rack or something. That's
Mhm.
when I get that error.
Okay. Nice one. So please confirm if it's when you're using ChatGPT and putting in prompts, or using the ChatGPT web version, or using the or making use of the API call. But I suspect you're talking about using the web version.
Yeah, both using the website and the even sometimes the same application, although it do resets after some time, it do resets, but as at that time, if someone is using it maybe professionally, so you know that it can cause a little issue for that person doing the work at that period of time. That's what I'm trying to emphasize on.
Okay. I mean, again, I would respond as much as I know is there are tokens, right, that are offered for use, like Kabir mentioned, depending on the what you are using, on the model you're using. And if it's a free version, then you have limited tokens. Even the paid version has certain tokens, has certain tokens you use, and once you exceed it, then it resets after 24 hours, right? So again, if you're also using the APIs, then definitely there will be limits to what you can do with the calls you can make via the APIs. That's again, if we bear that in mind, I think the interesting thing is to understand the limits you have, and then work within those limits. It's like typically calling APIs, maybe your free access to a certain API, or if free access to maybe a news API to collect data. It's always ideal to understand the limits you have. Some limits are based on time and dates. Some limits are based on the number of calls, right? So Kabiru said he started a data engineering course where he's learning to build scalable data pipeline. That's interesting. Um, Manuel says, on a lighter note, I ran a research on some of my results to understand the real world translation of my results to business implications. And out of the six LLMs used, only one got it accurate. Always cross-check results. Um, I mean, there's a whole lot. Like I don't know. Let me put this conversation out there. I almost always not find myself in a situation where they say stuff isn't really accurate for me. Why? Because I generally don't use ChatGPT for accuracy. I use ChatGPT for help, right? So um, I sort of have to find a way to cross-check how accurate whatever it is I'm doing in reality. Like if I was to do an analysis on how well students are taking in on how students are taking in or maybe on how students understand what I teach, I typically would want to use a survey, right? And then of course I have certain reference points and add markers that say, okay, this is working and this is not working. What ChatGPT typically does for me is how I go about building this survey and all. So at the end of the day, I try as much as possible to find out if there are markers and how I could, connect to it, if how possible, how true this. If for instance, I say, I think my students are understanding what I'm teaching, then I find a simple way to find out how true that is and still getting the information from them, right? So that's how I see it, but I don't know if it's the same thing, but at the same time, using ChatGPT to confirm accuracy and a lot of stuff is pretty subjective and down to a lot of things. But again, it's my opinion. Please feel free to share your thoughts on that. Yes, Emmanuel, please go ahead.
Yeah, hey, good evening, everyone.
Good evening.
Well done. So basically, I use ChatGPT. As you said, it's actually not wise for full-on research confirmation, but I use it to understand business application scenarios that I'm not used to, especially like in a market that I've not gotten into, maybe health. I've done my analysis, I've gotten my results, but I really don't understand the real life application of okay, this is what my data is saying, but how does it apply in the field? What does it mean when, okay, let's say we are talking about census data. What does it mean when the population drops by so percentage? And if it's historical data, like the one that I had to do the research on, what are the possible causes that could have triggered this drop in the population at this period of time in this very specific place? So that's basically what I use it for. It's easier or quicker for me than running Google searches, but I would always run searches when I have a streamlined set of results, a more streamlined set of responses, and then use that to confirm if what the LLMs are saying is actually legit or just something they're trying to pick up to give me an answer.
I mean that makes that. I mean, there's some sense to that. My own thoughts is, again, I think I always, this is how I see it. I almost always think about ChatGPT in terms of steps to do stuff. Because I have this sense that the brain cannot keep a lot of steps together. And then so for me, it's just a reminder of the different steps I can use to do stuff. Now, confirmation of stuff, again, like I mentioned, this is just my thoughts. And I mean, I see what you're doing and I can always walk around them. But for me, that's how I often see it, because I and maybe my thoughts will change on that, but I've always figured that generative AI tools almost always lack the nuances of what's happening on the ground. And so that's why when it comes to that part, I'm skeptical. So I'm always the guy that I often use it like a documentation type stuff. Like, okay, tell me the steps that I've forgotten about this. Tell me the steps on this. Tell me the intuition around this, this, and this. And when it's time to do stuff on the ground, I just be like, all right, I'll use that step from ChatGPT, go on the ground and see what I can do with it. But again, sometimes they connect. Sometimes it gives me insights. It gives me foundational insights. Like if I was to do a presentation, it would give me a foundation of what I could do. But in reality, I would almost always try to see what's happening out there and compare it to what it has given me. But again, it's a mix and match. Everybody has different ways. So I appreciate the way you use it. And thank you for also sharing. I hope you can also pick out from the way I use mine. And again, guys, feel free to also share how you use generative AI tools in your learning curve. I mean, I figure a lot of folks, would pick up from that and get insights from that, right? Also, generative AI tools are very powerful, especially in the teaching space, which is an area that I'm super involved in. I recently jumped into someone on LinkedIn that her work is around leveraging AI tools for um, instructional design. And I find it fascinating to see how both of them come together. Also, there's a research on how students are using generative AI tools, and they sort of, you know, you know, bringing up new ideas on how you can also use it, like kind of like reverse engineer the way people use chat GPT, sort of reverse engineer a lot of things, like reverse engineering the way your lecturers teach you in order to understand what they're saying. And in that way, by figuring out how they use it, you can also use it to understand how they hope to understand what you're teaching them, which is, a lot of reverse engineering and all. So it's such an interesting thing. And so if you have thoughts on how you use the generative AI tool, feel free to share, right? And you can also hear from other people and all that, right? So yes, interesting conversation. Again, folks, anyone done any stuff for the week? For me, the week has been really, really difficult. I fell sick. I had a lengthy illness, and one of the toughest aspect of being ill is also keeping up with work. And you get to hear a lot of people say, "Oh, this is the period where you get to rest," and which is fair, right? But at the same time, when you have a lot, um, a lot on you in terms of the machine that keeps moving, like a startup, and like the work that is happening, you figure out that it's really, really important to, in between the rest, just pick out time to do a few things. But it was awfully difficult. Um, in between the illness, I had to take like 2 to 3 classes sessions, and once I was done for any class session, it was almost like my joints were on fire, right? And it sort of made me appreciate how it feels like when I'm feeling well and taking classes, and when I'm done, I just sit back and be like, okay, start to reflect on what I picked up for the day. But right after those sessions, I have to just reflect on how weak my body is. But there was a lot. There was a lot of learning. I got into that, and so I appreciate a lot of it. Um, Really interesting thing that happened this week was having a conversation around cybersecurity and solving financial crimes or fraud in the fintech space. It was really an interesting detour in my learning circle, and I had that meeting in one of the worst ways, in one of the worst situations. But yeah, it was really interesting. I was able to return back to my data mentors classes. I think I enjoyed coming back to that. I struggled through having my live classes for old school, but I still managed to do all those. When I was done, I just go back to bed and sleep. And then the sleeping part of life, I started to appreciate it a lot. When you sleep and wake up and you feel good the next morning, you just hope you can't wait to get back to sleep. Unlike before, where I start to grumble a lot when it's time for sleep because I start to think, oh, there are a bunch of things I haven't done. So yeah, so that's been the week. I started something last week, and I started something 2 weeks ago or 3 weeks ago in my let me share my screen in my business intelligence community, which is for the data mentors program. No, the Tableau Saturday. I started to learn stuff. So I am signed up to Statista, and Statista shares newsletters. So if I check, so I have newsletters I receive from Statista. For instance, you see stuff like this: vaccination rates are stagnating, and so you see This is on immunization and infectious disease surge and vaccines stagnate and stuff like that. So I started the stuff where I get to read on, on stuff like this. And I found it really, really great. I get to learn stuff. I get to learn stuff consistently. And so yeah. So I started this for my Tableau Saturday sessions. So either at the beginning of the session, we read one of these. And it's super interesting to see the knowledge that is gained from it. We have these are reports by statistical data journalists, and then it sort of helps to it's knowledge to pick up knowledge and understand what's going on in the world is really interesting. Last week we looked at, this week on Saturday we looked at mobile money, the influence of mobile money on financial inclusion, and then how mobile money is playing a role in financial inclusion, right? And it's such an interesting conversation. The week before that, we talked about population, the world's population. I also, it's such an interesting thought that in 1987, July 11, the world was reached 5 billion individuals, and I mean 30, close to more than 30 years later, the world has gone over 3 billion on top of that. And so we read this, and so I'll encourage folks, find a way, especially in the data space, to pick up knowledge on how stuff works, right? The things, just jump on statista.com and sign up for their newsletters, and then you'll get stuff like this. You read up about it and you see there's so many information, there's so many there's data around that will put perspective to the things you want to learn as a data scientist or a data analyst or someone who's into business intelligence. The great thing about not just the information, for instance, you see stuff like this that says you see stuff like this saying in 2024, 14.3 million children worldwide were classified as 0 dose, meaning they have not received a single vaccine. You get that? You see, and then like conversations, stuff like 0 dose, like these are like some technical terms that you typically understand, and this small information like this can really be interesting, how they help you to put things in perspective, right? So I'm encouraging folks to pick this up and learn. Earlier in the Data Science Sunday, I always used to talk about the SDGs. I'll still tell folks to check this out consistently, and you see a bunch of stuff that you want to read about, right? And make sense of. This one is also another one. Put in your email, get it, and then every time get as much as possible to read up on what's going on. You see stuff like this. See this information. Like as for measles, global coverage improved significantly between 2004 and 2016, but has since slowed. In 2024, the global measles vaccination rate reached 76%, up from 71% in 2019, yet still well below the 95% threshold needed to effectively prevent outbreak. These things are really great information that you typically want to know about. And of course, this could also be a way for you to keep up with information. I seriously believe keeping up with information like this helps you as a person. You get to know stuff. So again, look at this information here. So according to the WHO, 60 countries experienced major or disruptive measles outbreak in 2024, nearly double the number recorded in 2022. The primary reason for low vaccination coverage remains limited access to vaccines in certain regions. However, the WHO also highlights the growing threat posed by misinformation about science and vaccines. This was really a very huge thing during the COVID. There were lots of conversations about if COVID was really true. I was really I listened to a lot of people say stuff like, you know, like that. You also hear conversations on why people think that the cancer may have vaccines, but some rich individuals are covering it up so that they could use it on themselves. You know, you hear stuff like that, and this misinformation is real. It all depends on which area you're coming from. A bunch of people. I know a friend or someone I've known in the past that believes that vaccines are just a way to kill people. So, and he says that he'll never let his children have it. So, these are really real information, and human beings are out there, you know, carrying this information and rolling with it. So, and to know what is so really interesting about it is that he works for an international organization. So it's wild. So and right after that, you get to see visuals. You see visuals around talking about um, vaccination rates are staggering, the evolution of worldwide vaccination coverage against the following diseases of pathogens. So you can see that tuberculosis, diphtheria, tetanus, and pertussis, poliomyelitis, hepatitis B, measles, and rubella. And you can see all that, and you can see, you know, you see that at a point it was low, but then there was sort of like an increase, and then all of a sudden there's a stagnation. And you can see the share of the target population vaccinated in a given year. Sources WHO and UNICEF, which also gives you a sense of how to build visuals to communicate your thoughts, because building visuals for storytelling is super important in the data space. So yeah, so this is one way I try to improve on in our Tableau community. I enjoy it a lot because it gives me the opportunity to learn something new. So I would encourage you guys to do it if you can, in whatever space you are. Just find some knowledge. It could be random. Mine is random, so because every time I look at the emails, yes, you see, we looked at mobile money. Here you see UNESCO World Heritage Sites, where they're located. You can see this, the US inflation rise in June as the first tariff effect sticks. Sure, you can see that. You can see stuff like, oh, this is just a personal one, but try it out, check out stuff, and then read up. It's really cool. It's something I would encourage anyone to do. So yeah, so that's that for one really interesting aspect of the week. Right. Do we have any questions? Do we have any thoughts on what was shared before we go into the next session, where we'll be talking about Estimator APIs and their guiding principles? Any questions?
Hello, sir.
Yes, please.
Yeah, did you learn have you learned cybersecurity, or you are just a, let's say, maybe in the an intermediate or professional?
Oh, okay, so I haven't learned cybersecurity. However, in my community, as part of the director of community and people, I am building. I need to influence the community to grow, and so that's why we have this. We are having these conversations. At Scholar Innovation Hub in Kaduna, we are, as part of our partnerships and part of what we need to achieve, part of the mandates we have is to leverage on cybersecurity to reduce fraud, financial fraud. And our targets are fintechs and banks. But we're using a community-driven model where we get people to learn cybersecurity. So our cybersecurity community at Collab is over a year old, right? So what we are doing is now is trying to get them, whenever they are doing their projects, to focus on solving problems like this. Now, what I have also taken from it is that I'm now going to be moving that conversation also into the data science space. So don't be surprised here. You're going to see us talk about data around and conversations around cybersecurity, and what are the features that what are the features or what are data points that point to vulnerabilities in the financial space, right? So that's what I'll try to do. Part of what I want to do in the community is to start to have that conversation. So which means that in data science, I'll start to have conversations around cybersecurity vulnerabilities and what data science and cybersecurity and things that are happening in that space. So that's what I want to do. I also have this. I strongly believe that I can also pass it into other communities. So maybe we can, in the product design community, people can, build wireframes with, cybersecurity in mind. We can also look at the product management space, the project, the other spaces, the web development space, front end, back end, and the thoughts, what they think around security and all. So I think that's basically what it's like for me, right? But what it means is, as I have this conversation, I build my thoughts around it, and hopefully I might end up, reading through areas and doing analysis around, what conversations around cybersecurity, flaws, attacks, and vulnerabilities. But the one that I know is very, very important is, preventing vulnerabilities in our fintech space and our banking space. And I think that one is really going to be a game changer in Nigeria. Right, and thank you for that question too. All right, so we are going to be getting into the technical session for today. Today's technical session, we're going to be talking about Estimator, the Estimator API, and the guiding principles for the Estimator API. So before I get started, I'll just do a simple recap. I know you mentioned about a simple recap, but in the last episode, we introduced scikit-learn, which is a Python library with a solid implementation of machine learning algorithms. And one thing that it boasts of is clean, uniform, and streamlined APIs for building machine learning models. So we looked at that, and we did a focus on data representation in scikit-learn, and we also learned that data is represented in front when it comes to explanatory variables. Data is represented as n samples, n_samples, which are total number of the records, and then the number of the features, which are the columns, which are the explanatory variables. And then for the ones we want to predict, is represented as a target vector with just a number of response variables we're looking at. It was important to do this introduction because when building a model, representing the data representation is critical to how the model ingests the data, which is the input, and then interacts with it in order to build a foundational model or a benchmark model, and then how it now deals with unseen data. So I figured it was important to have this intro. Now, today, we are going to look at the guiding principles on the estimator APIs. Now, whenever we mention estimator APIs, we're basically talking about the, the statistical models themselves, right? There is a way to use this estimator. There's a guiding principle for using the estimator API with scikit-learn in mind. I say this a lot because when I started out learning data science, one of the first things I did was jump straight into machine learning. Now, when you jump straight into machine learning, there are a lot of missing pieces. Like folks know that you basically write, okay, from sklearn.metrics import this, but they generally don't understand how that works. And again, if you look at codes, if you go to Kaggle and look at codes that have been written by people, you find people who start off by cleaning their data, go ahead to do exploratory data analysis, use statistical analysis, and then have their data set to now have their input set, and then now it's time to build a model that will now have a preferred output. And now after that, there's also how to interpret whatever has been done. There's also why certain things are important. Like I am on data camp. I'm taking a course on a course on linear regression, and there's a conversation around the concept of determination, leverage, high influence explanatory variables, and how these residuals, what it means to talk about intercepts and slope, and how you can use these things how you can use simple linear regression models to understand the driver for all this. What does it mean to use one accuracy model over one accuracy metric over another? Why? What are the history? What's the history? What's the intuition behind it? And I think a lot of the time we miss out on all this because we are so interested in just building models and looking good about it, but the guiding principles and how data is represented with respect to the reality in the world eludes a lot of us. I don't know what causes a lot of the things that causes is how we learn. So I feel a responsibility to just intervene and do something helpful. So the estimator API. Now, there's a design principle, there's a design guide for how to use this estimator API in scikit-learn. And we're going to talk about this principle. Now, the first of this principle is let me put this as the first of this principle is called consistency. So this is one, it's called consistency. So what's this about? Now, when building a model, right, you are going to interface with classes, but in these models have classes, and inside these classes like functions and methods, which are used for building models, right? In consistency, all objects share a common interface, and all of them are drawn from a limited set of methods, right? So I'm going to say all objects share a common interface, right? And we would get to see this, and this common interface, what it basically means is and all of these things are consistent in documentation, right? So again, just to put this, let me put this here. They are consistent in the documentation. And do not worry, when out, hopefully would have enough time for me to do a walkthrough on this. Now, the second guiding principle is inspection. And we're going. Again, the really cool thing is we're going to see how this works. Now, this one is called inspection. It means that all specified parameter values are exposed as public attributes. So which means any parameter you're working with is basically out there for you to see. So that one is the thing. So all specified parameter attributes are all specified parameter values are exposed as public attributes. Yeah, public attributes. Next, so again, this third one is super important. It has a term. It's called limited object hierarchy, right? So here, limited object hierarchy. What does this mean? From a technical standpoint, the algorithms are represented by Python classes. Only algorithms are represented by Python classes. Data sets have their own formats, right? And parameter names are Python strings. So again, let's know that, right? Python classes algorithms data sets, they are either numpy arrays, or they could also be data frames or data frame objects. Yeah. Then parameters are Python strings. They use, yeah, so here parameters, Python strings. Right. So again, what it means is when you want to see a situation where a data set is like a Python class. So that's why I know like the Python the Python class will obviously have their methods and their attributes and all. Then their methods, their functions and attributes. Then of course the data sets would almost always be either numpy arrays or data frame objects. But in some cases you might find them there's something called a sparse matrix then parameters, the parameters you see in these algorithms are almost always they are Python strings. So if you see something like n underscore maybe value, you know, it's a string, right? So no, yeah, parameter names. Sorry, parameter names. So yeah. Now the next guiding principle here, and this almost reminds me about the principles for creating variable names and all. Now this one is called composition. Now many ML learning tasks are expressed as sequences, right? Of this learning tasks, there are sequences that are fundamental to the algorithm. So so if you're trying to put up like an ML task, you almost always see that this ML task are just broken down into sequences, right, of the algorithm, right? So what scikit-learn does is it uses this whenever. Again, like I mentioned, we're going to see a very good use case when we start doing something pretty simple. So here, these are ML tasks can be expressed as sequences of more fundamental algorithms, right? So this is basically, if you look at like if I was to call an ML algorithm, you notice that those things that you expect the algorithms to do are basically the ML tasks that are underneath them, right? And that's what okay, thank you. And that's what you typically see when you look at an algorithm. You see that it's broken down into those sequence of ML tasks. Then the final ones are called the final one is called sensible defaults. Now, anytime you use a model, right? The library often starts out with something called any ML model or any ML class would almost always have an appropriate default. You get me? So they're called like they're the expectation for a user specified parameters always start off with a sensible default. So if you use like if you call it the first time or you instantiate it, it will have its sensible defaults. Obviously, we now go on to either start to tweak them as we proceed. So so just know that this is a thing. So here, models require users when models require user specified when models require user specified parameters, right? The library offers an appropriate default, right? So the library offers an appropriate default. So basically that's one side to it. So now these are guiding principles to it, right? So in practice, right, sklearn makes it really easy for you to make use of these things, right? So that means any machine learning algorithm in scikit-learn is implemented via the Estimator API, and they have this guiding principle, right? So you see the consistency, the inspection, their object hierarchy, their compositions, and their sensible defaults. Now, the next thing is we're going to look at the common steps in using um, the the scikit-learn estimator APIs, right? So these are common steps in using, let me make this a small one. Common steps in using the scikit-learn estimator API. Now, these steps, you would almost always see these steps being used, almost always, right? So let me break these steps down. Now, the first step you would always see is you would choose a class of model. So this one is choose a class of model, right? And this is done by importing the appropriate estimator class, right? Say this is the part we're talking about. This here. So you choose a model, and it's done by doing basically writing an import statement, right? You choose a model. Now the second part is to choose you choose the model's hyperparameter by instantiating the desired value, right? So remember we mentioned this when models require user-specified parameters, the library offers an appropriate default. So here you choose you choose the model hyperparameter by instantiating this class, by instantiating this class, which is this guy that you have here. This is the first one. So you choose the model parameter by instantiating, and they have sensible defaults. So that's what they're going to use by instantiating this class. 3, you arrange your data, you arrange the data into a feature matrix and target vector. You arrange the data into a feature matrix and target vector. I've mentioned this here, so this is what it is. Sometimes it's even done, right, before we even get to this point. So that's why at this point mostly at this point you've already done that. So what almost comes next is fitting the model to your data. So here you fit the model to your data. So that's what, yeah. And here, when you do this by calling the, fit method. Then the final part of it is to apply the model to the data, which is what you have arranged here. Now, for supervised machine learning tasks, we would often predict labels for known data. So that's why you almost always use like the predict method. For unsupervised machine learning, we will often transform, right? Or infer the properties of the data. So you would almost always use stuff like transform, or predict. It all depends. So transform often always comes in. So most times when you see applying your model, it's either there's always a bit of a nuance to unsupervised machine learning and supervised machine learning. So that's these are like the basic steps that are often happen. So these two things really, really important to set stuff going. Now let's do a few stuff, right? Um I am going to we're going to sort of create um uh should I create or yeah, we could do that. No. So what I'm going to do is we are going to perform a supervised learning example, right? And then when we perform this supervised learning example, we would now do we'll now take all these steps. Now, a lot of things are going to happen here. There is a lot of assumption that we have done exploratory data analysis and all, and we now have our data, right? So here we're going to perform a simple supervised learning example, a simple supervised learning example. Now, when we do these things, whatever we're going to do here, right? We are going to, whatever we're going to do here, we are going to take advantage of these steps, and then we would also see, some of these things in play. So the first thing, that's why I mentioned this part where we typically have done this guy first before we get started, right? So the first thing I want to do is, I told you the idea would be that we already have our data. So to get our data, I'm going to import pandas as PD. I would import numpy as NP. I would import cborn as SNS, and I'll import matplotlib.pyplot as PLT. Now, for a lot of people who are starting out in machine learning, who are starting out in data science, and are super interested in getting started by doing all these things and writing all these things and not really knowing why it's important, over time you find that you are used to these steps but not understanding what the hell these steps mean. So I think that it could be really, I think it's sort of dangerous to that part, because you get to a point where you're just doing things step by step, but I mean, you don't know why the hell you're doing it, but you're doing it, right? So most times it's important. I know that sometimes you see your notebook, these guys are already imported, but understand that these steps were taken from day one, because, from the very beginning, because you needed to convert your data to a pandas data frame. And remember that, just as it's mentioned over here, that data sets have, they're like this. So it's only important that since you're going to build a model in future, your data set has to either look like an array, or have the array format or a data frame format. That's why it's important to learn some fundamentals like how to use pandas, how to use numpy, and understand the intuition behind rectangular data, that then you can understand n_samples and you can understand n_features. You would also understand what it means to use what it means to use numpy arrays, and what it is to convert maybe your data into an array, and what the implications are, right? Guys, Just give me a second. I'll be back. Just a second. I'm back. It was threatening to rain, so I'm gonna let my clothes outside. All right, guys. So again, so we're going to perform this very simple task. Now it's a simple it's a classification. Um we're going to predict the we're going to predict we're going to use the iris data set. So first off, so here's our data set. So we're going to use the Seaborn repository to have that. So we're going to call this iris underscore data. And in here we're going to say SNS dot load data set. And here we're going to have iris in here. So if we have iris underscore data dot head, we would use this. So you would almost always see this used as an example for machine learning models. Also, this data set dates back a long time. It's like legendary. So it's like 1936. Right? It was used to do a lot of experiments. So the first part of it has the explanatory data, which are the inputs. And then, of course, this final part is the output. And the output is discrete. So that's why it's a classification. So these are our data. So at this point, our data is a data frame. Now, that's why I mentioned this third part would, we'll arrange our data into this, but we'll get to that part. Now, typically, whenever we're playing around with data, we want to ensure that our data takes this shape, the feature matrix and the target vector, right? So what I will do is, and remember there's a convention that your feature matrix is basically your explanatory variables, and we always use X to represent it. So to that end, I'll call this X underscore iris. Now, X underscore iris will basically have our data that the data would just be is going to be the explanatory variables, right? So what I'm going to do is I'll take iris data and then I'll drop this guy because I won't want to have my response variable. So I'll drop this. So when I drop this, I'm going to drop species. This is what I'll drop this one. Then I'll indicate axis equals to 1. Right, so once I drop this, then you can see I have my X underscore iris dot head. And you can see that it's just this guy without it. And to show you that the data represents a feature matrix, which is n underscore samples and n underscore features, which is the total number of records it has and the total number of columns it has. If I check X underscore iris dot shape, you can see that it's representative of this guy here. This is what it is. Now, the other part is when we reference the data as y, so which is our response variable, right? So I'll call this y underscore iris. And inside of it, I am just going to have the iris data. And I'll just reference species. So this, it will just be the only thing inside. And again, because this has to reference the target vector, which is just n underscore samples, right? If I was to check the shape, I would have y underscore iris dot shape. And you can see it just has only this. And so you must create this before you start to build, before you start to instantiate your model in it, so that you know that's the data representation for the estimator for use for building your model with it. So this is super important before you get started with what you're doing. Super important. All right, so we have now done 3 before then, right? We've done 3 before then, right? So this is it. So now let's start with 1. Let's choose a model. Let's choose a model class. So so our first so let's build a simple classification model. So the first step would be to choose a class, a model class, or a class of a model. Now, remember, but before we do that, we need to split our data into a. Sorry, we need to split our data into a training and test set. Now, there's a lot that goes into this before then, right? We haven't talked about model validation. We're just doing very basic stuff. There are other things we need to do. So first off, we split our data into training and test sets, right? Now, if we do this, because we want a situation where when we train our model, which is traditionally machine learning is inputs, right? Then there's a model in between and there's the expected output. But when we do it, we need to be sure that the model performed really well, which is if the example was to predict if an email is spam or not, we have to split that email data into 2. So we'd have the one where we would train our model, and then we'll have where we'll test if it can actually look at a real model, a new data, and say, oh, this is spam or this is not spam. So that's the first thing we do. So to get this done, we would have to use a model class to perform this task, right? So we'll say from sklearn dot model selection. This is what it looks like to. Question? Okay, this is what it looks like when you're like importing a model class, right? So from sklearn would import train test split. So this is one. Again, remember there's a conversation around model validation, or we haven't started talking about that. So here, what we're doing is just a simple, taking out a model. We're just doing the very basic stuff. Now here, we now want to break our model, split them. So we're going to have X train. You would almost always see this normally, and you have X test. You have Y train, and you have Y test, right? And then we use train test split, and then we introduce our X underscore iris and Y underscore iris here. Then we'll use a random state. The random state basically says for replicability or reproducibility of this model, we can choose a state where we would either want to, if we want to reproduce it without an issue, or if we think we want to test it on another set of, another sort of like a raffle draw, just to be sure there's some level of consistency. So I'll just use one. Now here, by default, right, there's supposed to be a train and test. And if we don't provide the train and test, by default, it is going to use, I think 25%. Yes, it is set it to 25%. So which is okay. So I'll use that. So when I run this, remember that this was 150. So right now, what we're going to have, X train is going to be 75% now. So if I say X dot shape, you see that this is 75% of, yeah. Yes, I think so. This is the percentage of which it is. If it's 75%, or what the percentage is, it has, this is what it is. And for Y train dot shape, you can see, sorry, Y tests. You can see this is the remainder of it, right? So now we've gotten this set. So now let's now do our take the 4 remaining our steps as we take them, right? So with our data arranged, we'll follow the following steps. So with our data arranged, you can see over here we have arranged our data, right? So we can do 1, 2, 3, 4. So with our data arranged, we take our first step. This is first, right? And if we go back here, choose the class of model. Now, guys, the class of model we're choosing doesn't matter, right? We're just going to pick up any class of model. So here I'm going to say from sklearn dot naive Bayes import Gaussian MB, which is a model. So this is the first step, which is to choose a model class. Yeah, to choose a model class. This is one. Now, the second step here is basically to instantiate the model. So to instantiate the model, we'll create model, and inside we will now say Gaussian MB. Now this is that part where if we instantiate the model, we would now use sensible defaults. Inside here we have sensible defaults, right? Inside it will have some sensible defaults inside of it, right? So we run this. So we have this already set in, right? So here, this is the second part of it, which will be instantiate your model. When you instantiating your model is different from fitting your model. So here we instantiate the model. So we've run this. Now the third part of what we're going to do, which is the third, would be to fit the model to the data. So here we say model dot fit. Sorry. Model dot fit. Now model dot fit means inside of it we're going to put X train, which is our training data, and then Y train, which is our the data that was to be predicted, right? So which is this two. We picked this guy and this guy. So this X train and Y train, and we fit it inside of it. So here we fit the model. And then we run it. So you can see that it's been fit. Now, the next thing with the fourth part of it is we are now going to predict on new data. Our new data is our X test. We've not seen it before. So here we are going to do our fourth. And here we would now say, we call this Y underscore model. And inside of it, we say model dot predict. And then we'll go and take X. We're going to take X test. So this is the data. Remember, we split it into X train, Y train, X test, Y test. So this X test, it hasn't seen this data before, right? So we now predict. So this is where we do the prediction.
Hello, sir. Hello, sir.
I'm listening.
Please, I'm sorry for interfering. Please, sir, what you are explaining, I can't see it here. So I just want to ask that have you shared the screen?
Yeah, my screen is has been shared for the past like 20 minutes.
Okay. Maybe I'll have to check
Could
it
you just
later.
refresh? Yeah, refresh your screen. Your screen.
Okay, okay, sir. Okay, okay. Okay.
All right, so I run this, so we've done a prediction. Now, yeah. Now we have basically done this. Now the next thing we will do, so which is the first four, right? And then we can now do, which I didn't talk about this fifth part, but this fifth part is where we want to test how the prediction happens. So the fifth part is I will now import the what I'll use the accuracy class, and so I'll say sklearn dot metrics. Then I'll import accuracy score. Now with this, I will now basically say accuracy score, and I'll now take the Y test, which is now the predictions that were made, right? With the Y test predictions that have been split for one side, and said, look at the model I created and tell me how good, because when you are doing a prediction, you're going to predict and you're going to have observed, and which is observed our training data, and we have predicted the one we've predicted. So we look at observed and predicted, and we have them together and say, how well did this perform? And then we run this. Now, it typically tells us that it performed 97% accuracy, which for the most part, right, is okay to have it as baseline stuff. But we'll be having a different conversation on whether this is okay to now say, oh, 97% of the time you can predict a flower species, but that's a different conversation. But what we have basically tried to do is to show you, right, the steps that are taken when using the API class, the guiding principle, then the common steps we would use to predict using scikit-learn's estimator class, right? So these are the things you do typically, and then you go on to take your data and then predict with it. See, there's a lot that happens before this, but for now, this is just the first part of it. From here, we'll start to break things down into what does it actually mean, right? If this was a business case, what does it actually mean? So this is just the steps, right? And hopefully from here, we will start to make sense of, how to do these things consistently and how to move on from one step to another. So yeah, so that's this is it for the technical session. Please, if you have questions, feel free to ask. You have questions?
Hello, sir. Hello, sir.
I can hear you.
Yeah. The name of the app is Jupiter.
The name of what?
Is the name of the app Jupiter?
Jupiter.
Yeah, Jupiter. Okay. Is that the name?
Of that's the name of
Hello.
can you hear me?
Hello.
Yes, I can hear you.
Hello.
I can hear you. Do we anyone do we have questions? Please go ahead.
Okay, am I audible? Okay, the question I have is that I followed from last week's notebook and I couldn't bring in the Y iris.
Say
I couldn't bring in the Y iris dot shape. If you go up a bit after we dropped the species column, yes. So the Y iris, I don't know why I couldn't bring in the Y iris.
you don't know why what, please?
I said I don't know why I could not call up the Y iris that we have here.
You say why we didn't call it up.
No, I tried it on my end, but it didn't work.
Did you create it?
No, I did not create it. I'm working with the
Create it. You can extract the species, and then you have it here.
okay.
Yeah, you have to. Yeah, because remember that the main data set is the iris data, and it was from there I created X iris, where I dropped species. So which meant I only had my explanatory variables here. Then after that, I went to use the same iris data to extract Y iris, where it's just the response variable, which are in the iris data set, which is the species themselves.
Okay.
Given this length, width, length, and all, you can predict which species of iris flower we're dealing with. It's also just like the penguins data set, where they'll tell you with the various types of bills that penguins have, you can predict the type of penguin we're talking about. So these data sets basically help you learn how to use build machine learning models before jumping into the real life stuff.
Okay, thank you very much.
Welcome. Yeah. Amir, yes.
Hello, Pablo, and good evening, everyone. So Pablo, I was wondering if maybe for the sake of others, you could maybe show us the height of the y-iris, that is the response variable or the target variable. Like, let's try and make the notebook much more clearer for the sake of others, so that they will know that like we are using these particular features to predict this target or response variables. Thank you. I mean, like,
so you say you want me to do what?
Like, I want you to bring out the head of the y-iris, that is the response variable, for the sake of others and clarity.
Okay, you mean this?
Let me check.
See the
Exactly.
head?
Yes. Perfect. Yeah. Yes, that's what I'm talking about.
Yeah.
So thank you.
You're welcome. So this is the response variable. This is what we are trying to predict. This is what we created. So this is a response variable. And the x underscore iris dot head, this is the explanatory variable. The explanatory variables. So this is the both of them. This the two things. In reality, right? What this is basically is saying if this would have been the emails. Sorry. This would have. Sorry, I need to get this. Let me get this out. So in reality, this would have been like our email data, and this one would be spam or no spam. So that's basically what it is. But again, remember that the interest here is the steps, right? The steps, and if you go watch our last session, it was important to understand data representation, right? It was important to understand data representation for scikit-learn, then come down now to understand their guiding principles, and then the common steps. Then we did this. So which means is if in future we are working for a company and they're saying, look, from these features we have, can we predict who will what's a fraudulent transaction? Then we data we can have the fraudulent transaction column, which is going to be our response variable, our target, and all. And then we would have the features that can tell us if something, right, has a high influence on our variables or it has this leverage on it. And so those are the things we're going to we check. But that's going to be the future in future when we are taking them one step at a time. Okay, guys. So this is it. This is for the technical session. Right after we are done with this, you can jump over to my YouTube channel, Data Science with Pablo, and you get to see the recorded session, and you can watch it over again. Right. But if you have questions, please feel free to share. If you don't, then we'll be wrapping this up. It's raining on my end, so I'm trying as much as possible to be done with this before it starts to affect my internet. I know you guys will have heard the Starlink story. All right, guys. Yeah.
Yeah, Pablo, I just wanted to, share this with others in order to enhance the learning and understanding on what you have done today. So I just wanted to give them like a motivation. So basically what I wanted to share is that what we have done today, I think in machine learning, I just wanted to add on what you have said. So what we have done in machine learning basically is mimicking what ChatGPT is doing. Basically, this is how ChatGPT works. Like we have a lot of words. These words are broken down into tokens, which are also broken down at the very basic level into numbers, just like this our data set. So these numbers are now trained like exactly the same way, but with maybe more sophisticated algorithms like with transformers. So I don't want to go deep into that because we are just starting this. So with like ChatGPT is not using naive base, sorry to say that, but it's using much more sophisticated algorithm. So and it's also predicting the future in the sense that it's predicting just the next token. So and then again, like ChatGPT, you can't train something like ChatGPT on your personal computer. That's why we have like large clusters, to train them. And then there's a lot that we can learn, before we get to that level of what they are doing with ChatGPT, which I believe one day this particular community will get there, hopefully. So That was what I just wanted to share with others.
All right. Thank you so much. Thank you so much for that future perspective. All right, guys. So again, like I told you, if you have questions, feel free to drop it. You can also drop questions in our community groups, right? But again, I'll encourage you to watch this again and then try to make sense of it, right? Okay. If we don't have questions, we'll be drawing the episode 138 to a close, which is the 27th Data Science Sunday of the year. And please feel free to always reach out. The community is there. Send questions. Practice, practice, practice. Surface learning is a very difficult thing. If you just learn all these steps, but then you don't know how it connects to reality, then there's almost always going to be a gaping hole in your learning curve. But again, focus. Just put your focus on what you want to do. And yeah, please go ahead.
I just wanted to ask this your what do you call it? Your Jupyter notebook. I notice it gives you details of parameters. I mean, gives information about let's say when you open a particular method. Does it come with the? But I've tried to get that on my Jupyter notebook. I've been unable to. All those suggestions and things stuff that you have on your Jupyter notebook. I don't know.
Yeah.
I don't know. Maybe you get what I'm saying. Like when
Yeah,
you
Yes.
instantiated the model, it shows all the information you need. Yeah, stuff like that.
So
Do
actually,
you have an idea?
I do it myself.
Is there something to install or?
No, I'm the one that is doing it myself. So just watch if I put this cursor in here, I use Shift and Tab on my keyboard, and it will show me.
Okay, Shift Tab.
Yeah, Shift and Tab.
Okay.
It will show me. It will just show me the documentation. Also, another way you can do it is you can basically remove the brackets and put a question mark in front, and then run it, and it will bring everything out for you.
Oh, all right. Thank you.
Sure, you're welcome. Guys, any questions? Please feel free to ask if you have questions. All right.
Hello, sir.
Please go ahead.
Hello, Pablo.
Go ahead, please. I can hear you.
Yeah. Was it after you gave it the metrics? That's when it displayed the sepal length, sepal width, pent length, and pent height.
No, it's the data set itself. Here, it's an existing data. I got it from here.
Okay.
Yeah, it's a data set itself. It's in the Seaborn repository. It's called the Iris data set.
Okay.
Yeah. You can load it from here and you can start using it.
Okay. Then the second question is that Jupyter, is it only for ML?
So I mean, with a Jupyter notebook, you can do data analysis, you can do data science and machine learning. They were built for it. It was built for it.
Okay.
It's a product that was built specifically for learning data science, machine learning, data analysis. So yeah.
Okay. Okay. Thank you very much.
You're welcome.
I believe as time goes on, we will continue learning.
Yeah, definitely.
Thank you.
All right, guys. Thank you for all the questions. Do we have other questions? Anyone with questions, please feel free to share.
Then please kindly drop the Telegram and WhatsApp group again.
Okay, I'll do just that.
Okay, and if possible, your email. So for any other discussion.
Okay. So I'll drop this here. I just shared this. If you need my email, so here's my email. If you need that, I just shared the email, so you can reach me on this email. We have questions. All right, guys. Again, I'm very grateful for everyone that joined in. Please, let's do it this next week and keep doing this till more than 1,000 episodes. The idea is use every step is get you closer to what you typically want to be. But again, remember, between Sunday and next week Sunday is another opportunity for you to keep chipping in very tiny steps into becoming that world-class data scientist, ML engineer, AI engineer that you want to be. All right.